This video covers multiplying polynomials. I want to start this video by writing the first problem down and then going through and talking about how we're going to solve it before we actually solve it and writing all the steps down. So the first problem is going to be x plus 5 times x plus 2. And the first thing that we're going to do for all of these problems is we're going to rewrite the problem. So that's going to be the first step, is to rewrite the problem. We want to take this first set of parentheses and we're going to break it in half. So we're going to break the first parentheses into parts. And we're going to multiply the parts by the second set of parentheses. So let's actually do that. So let's take this first set of parentheses. We're going to break it into an x and a plus 5. And we're going to say x times the second set of parentheses, which is x plus 2. And 5 times the second set of parentheses, which is x plus 2 still. All right, so that's the first thing we want to be able to do. We want to rewrite the problem before we do anything. Then the next thing we want to do is we just want to distribute. So just like solving any equation or simplifying any expression, we want to get rid of these parentheses. So we're going to distribute in order to do that. So I'm going to say x times x, which is x squared, and x times, and remember this plus sign goes with this 2, so it's x times a positive 2, so that's plus 2x. First thing I need you to remember is that when you multiply a variable times another variable that is exactly like it, it's not 2x, x times x is x squared. Then x times 2 is 2x. There is a difference in the value of those two terms right there. And then we're going to take this plus 5 and we're going to multiply it times x. So plus 5 times x is plus 5x. And plus 5 times positive 2 is positive 10. Not positive 0. Positive 10. So we've rewritten the problem so that we could distribute. Then we've actually done the distribution. The next thing we want to do, is actually the last thing we're going to do, is we're going to combine like terms. Now remember, when we say combine like terms, they have to be terms that have the same kind of variable, and those variables have to have the exact same kind of exponent. Now, most of the time, not all of the time, but a lot of the time, you're going to find that if you will set your problem up like this, the terms in the middle become your like terms. So x squared is not like any of the other terms in the problem, so it goes into my answer. And then I have a positive 2x plus 5x, so I actually add those together for 7x. And then I have a constant, I have a 10 here. There's no other constants, no other plain numbers in my problem, so I'm just going to put plus 10 as the final answer. So people don't like it. They like it when things equal just one number. But x plus 5 times x plus 2 equals x squared plus 7x plus 10. So you're going to get big, long answers like that you don't really like, and you feel like they're not correct, but they are correct. So trust yourself and your ability to do the math. The next problem is 2x plus 4 times x plus 3. So we're going to rewrite, we're going to distribute, and we're going to combine like terms. So let's rewrite first. We're going to take this 2x plus 4 and we're going to break it into two pieces, 2x plus 4. And then we're going to multiply those two pieces times that second set of parentheses. So it's going to be 2x times x plus 3 and positive 4 times x plus 3. So we've rewritten the problem. Then we want to distribute, so we're going to take 2x times x, which is 2x squared, 2x times a positive 3. 2 times 3 is a positive 6. And it was 2x times 3, so it's 6x. Then we're going to take positive 4, and we're going to multiply that by 3. Positive 4 times x. Positive 4 times x is positive 4x. And positive 4 times positive 3 is a positive 12. So we rewrote the problem, we did the distribution, and now we want to combine like terms. So I like to start at the beginning. I have 2x squared, don't have any other x squareds in my problem, so 2x squared goes in my answer. Then I have a 6x and a positive 4x. So those I'm going to combine together. 6x plus 4x is positive 10x. And then I have a 12. Don't have any other constants, any other plain numbers. So that positive 12 is going to show up in my answer. Remember, this is math. Things don't magically disappear and reappear. They all have to either be used to make something or they have to show up in your answer. Third example, very similar problem. X plus 1 times x minus 2. We're going to take this x plus 1 and we're going to break it into two parts, and we're going to multiply those by that second set of parentheses. X times x is x squared. X times negative 2. This is a negative 2 because this minus sign goes with this 2. So x times a negative 2 is negative 2x. 1 times x is positive 1x, and 1 times negative 2 is negative 2. And then let's do our third step, which is to combine like terms. We've got x squared, negative 2x plus 1x, negative 2 plus 1 is negative 1x, and then my minus 2 on the end down here doesn't have any like terms, so we're just going to combine, we're just going to bring it down into our answer. You don't have to have this 1 here. You could just simply write x squared minus x minus 2. This is what you would see on a multiple choice test. This is the standard way of writing that. But if you go ahead and put that 1 in front of that x, it's not wrong. It's just a little something extra that you didn't necessarily need. So something to consider right here in the middle of this is that you have to pay attention to the signs. Helps if I can spell signs, doesn't it? Pay attention to the signs. A positive times a positive is a positive. A positive times a negative is a negative. And a negative times a negative is a positive. Pay attention to your signs. Signs are the things that trip you up the most when you're working with multiplication. The other thing I need you to remember is that x times x does not equal 2x. X times x equals x squared. Now, these first three examples have all been a binomial times a binomial. And a binomial just means, hey, they have two terms inside the parentheses. I wish that they were always just 2 terms times 2 terms, but they do get bigger. So I'm going to turn my paper over. I'm going to divide my paper in half and do my 2 columns. So my next example is going to get a little bit bigger. I'm going to start with a binomial, x plus 2. But then I'm going to multiply times a trinomial, x squared minus 5x plus 4. This doesn't change how you solve the problem. It just changes how much multiplication you have to do. So, same as before. We just have more multiplication. So let's take this apart. We're going to say x, we're going to leave a little more space, and we're going to take a plus 2. And then we're going to take this second set of parentheses, and we're going to say x times x squared minus 5x plus 4. And we're going to put it behind the positive 2, x squared minus 5x plus 4. And then we're going to distribute. So there's just more multiplication because we've got 3 things in each set of parentheses. So x times x squared is x to the third. X times negative 5x is negative 5x squared. And x times positive 4 is positive 4x. Same thing here. 2 times x squared is positive 2x squared. 2 times negative 5x is negative 10x. And 2 times positive 4 is positive 8. Now, because this problem was bigger, because we had a binomial times a trinomial, you're going to have to go find all the like terms. So they're not nice and neat and right next to each other. You're going to have to go looking for them. So I have x to the third. I don't have any other x to the thirds in my problem there, so I'm just going to put x to the third in my answer. I'm going to circle it because I like to keep straight what everything I've done. I've got a negative 5x squared, and I have a positive 2x squared. So negative 5x squared plus 2x squared gives me negative 3x squared. So I've used this, I've used this, I've used this. I have a positive 4x. Oh, that almost got cut off. And a negative 10x. Remember, that negative sign goes with that 10. So 4x minus 10x is negative 6x. Use those two things. And then I have this 8 down here. He's the only thing left, so he needs to show up in my answer. So x plus 2 times x squared minus 5x plus 4 has a final answer of x to the third minus 3x squared minus 6x plus 8. If you don't have these numbers in this order, that's okay. As long as you have each one of these terms and they have the correct sign in front of them, that's still a correct answer. This is considered standard form, and this is how you're going to see me write my answers all the time, because standard form says start with the variable that has the highest exponent. So x to the third is the highest exponent, so I start there. And then everything else just decreases. So then I go x squared, then I go x to the first, then the last number will always be whatever doesn't have a variable stuck to it. If you've got more than one variable in your problem, you're going to put your variables not only in order by their exponents, but you're also going to put them in alphabetical order. But you're probably not going to see that for quite a while. In just this simple multiplication, we only use one exponent in these problems. So let's do another big problem like that. So 3x minus 4 times negative 2x squared plus 5x minus 6. Let's take this first set of parentheses. We're going to say 3x, and out here we're going to say minus 4. And then in between, and at the end, we're going to have that second set of parentheses. Make sure when you're copying the problem, copy it correctly. A lot of mistakes that I see in student work is not because they didn't know how to do the work. It's because somewhere along the way they copied something incorrectly. So make sure you're copying things correctly. Make sure that you're paying attention to your signs. Remember, the sign goes with the number behind it. So this is a negative 2x squared. So I'm going to say 3x times negative 2x squared. A positive times a negative is a negative. 3 times 2 is 6. X times x squared is x to the third. So a lot going on in all these problems. Then I have a positive 5x. I'm going to multiply that times 3x. A positive times a positive is a positive. 3 times 5 is 15. X times x is x squared. And then this is negative 6. And I'm going to multiply that times 3x. Positive times a negative is a negative. 3 times 6 is 18. There's not an x here, but there's an x here, so there needs to be an x in my answer. And then the same thing for the second half of the problem. This is a negative 4. Negative 4 times 2x squared, a negative times a negative is a positive. 4 times 8, or 4 times 2 is 8. And there's an x squared here, so there needs to be an x squared in my answer. And then negative 4 times positive 5x is negative 20x. And negative 4 times negative 6 is positive 24. So that's got all of our multiplication done. It's got rid of all of our parentheses. Now all we need to do is combine like terms. So I have the same variable all the way across the problem. This one has the biggest exponent, so I'm going to start there, negative 6x to the third. And I'm going to mark that out because I've used that in my answer. My next exponent is squared, x squared. So I'm going to say positive 15 plus 8. So I've got positive 15 squared and 8 squared. And when I put those together, I get 23x squared. So I've used those. Then I've got a negative 18x and a negative 20x. When I put those together, I get negative 38x. And then this 24 on the end doesn't have a variable. There's nobody to combine it with, so it's just going to show up in my answer. Let's do one problem that's even bigger, because they can just get kind of unwieldy. And I want you to realize they're not more complicated, they're just bigger. And bigger doesn't always mean worse. Just sometimes means it's going to take you a little longer and a little more space on your paper to actually solve the problem. So I've got x to the third plus x squared plus 2x times x to the fourth minus x to the third plus x squared. This is actually going to kind of go a long way across my paper, so I'm going to erase this line here in the middle so that I can get it all on there. I'm going to break this into pieces, x to the third, and I'm going to multiply it times the second set of parentheses. So x to the fourth minus x to the third plus x squared. So I've used that. Then I've got a positive x squared, and I'm going to multiply that times x to the fourth minus x to the third plus x squared. And then I've got a positive 2x, and I'm going to multiply that by that second set of parentheses. So it's still the same idea. It's still the same idea of take the first set of parentheses and break it into individual pieces and multiply those individual pieces times that second set of parentheses. It just makes a really long problem, but doesn't make a complicated problem because it just makes a problem with lots of multiplication. So x to the third times x to the fourth. Keep the base, add the exponents. 3 plus 4 is 7. This is a negative, this is a positive, so we're going to get a negative here. X to the third times x to the third. Keep the base, add the exponents. So x to the third times x to the third is x to the sixth. Same thing. Positive times a positive is a positive. X, 3 plus 2 is 5. This is going to be positive x squared times positive x to the fourth. So we're going to positive x, 4, 5, 6. A positive times a negative is going to give me a negative. Keep the x, add the exponents. And a positive times a positive is going to give me a positive. And x squared times x squared is x to the fourth. I feel like my numbers are getting smaller and going uphill as we go across the page. Then I've got positive 2x times x to the fourth. So positive 2x times x to the fourth is x to the fifth. 2x times negative gives me negative 2x times x to the third is x to the fourth. And then positive times a positive again, and we get 2x to the third. So there's all of our multiplication done. Now we need to go through and we need to sort out all of our like terms. So I'm going to start at the beginning. This is x to the seventh. There are no other x to the sevenths here, so x to the seventh goes in my answer. I've used that one. I have negative 6x. I have positive 6x. Those are the only 6x's in the problem. A positive 1 plus 1 means those two guys just cancel each other out. They're gone. One of them canceled the other one out. They don't show up in my answer. Let's see. I've got positive 3x, or positive x to the fifth, negative x to the fifth, 2x to the fifth. So if I add those together, positive 1 minus 1 is 0, and 0 plus 2x to the fifth is positive, not 5x to the fifth. Add numbers that don't happen. Positive and negative ones cancel each other out and leave me with 2x to the fifth. So I've used all of those. I have a positive x to the fourth and a negative 2x to the fourth. A positive 1 minus 2 is negative 1 x to the fourth. So I've used those. And then the last thing I have left is a 2x to the third. I don't have anything else left for this to even be combined with, so it's just going to show up in my final answer. You can leave this as your answer, but if that one bothers you, you just rewrite it. 7x plus 2, or x to the seventh, plus 2x to the fifth minus x to the fourth plus 2x to the third. 3 steps. 3 steps to solving these problems. Rewriting the problem, distributing what's in front of the parentheses to the parentheses behind it, and combining like terms. That's all you need to know for multiplying polynomials.